3 different age classes for the beetles, and I'll just go ahead and call those X, Y, and Z. And if I had to diagram this, then that first row is giving us information about what is coming into X. The second row is giving us information about what is coming into Y. I'm going to try a different color here. And that third row is giving us information about what is coming into Z. Then the columns are telling me where the information is coming from. So this 6 in the first row tells me that there's a flow from Z into X. With a coefficient of 6. In that second row, this tells me that there's a flow into Y from X with a coefficient of 1/2. And that bottom row tells me that there's a flow into Z from Y with a coefficient of 1/3. So that's what our diagram would look like for this. Now, if I were writing the difference equations for this, again, I didn't ask for those on the quiz, but if I needed to write the difference equations, just to give you a sense of some of the things from 8.5, to write those difference equations, I'd say that x sub t, I'd have x sub t plus 1, y sub t plus 1, and z sub t plus 1. And this would tell me that x is gaining 6 times z sub t. So whatever the value for z is now, 6 times that is flowing into x. When I look at y, I know that, and that's the only thing flowing into x. So if I look at what's flowing into y, the only thing flowing into y is that 1/2 times x, or 1/2 x sub t. And for z, the only thing coming in is coming from y with a coefficient of 1/3. So my z sub t would look like 1/3 y sub t. So I'm going to start with a diagram here. And we've got x, y, and z. So in this problem, we are told that 5% of the individuals carrying X will mutate to carry allele Y in the next generation. So we've got 5% mutation from X to Y. And I'll go ahead and write that as a decimal. So I've got 5% mutation. We're also told that X is going to mutate to allele Z 3% of the time. And then we're told that the rest of the individuals remain unchanged. So that actually turns out to be really important in terms of our overall diagram. So if the rest remain unchanged, we have to represent that still in our picture. So currently, we've taken care of a total of 8% of what's happening with the X alleles. That means there's 92% left that will remain unchanged or start as X and remain as, oops, I wrote 98, I meant 92. Remain as X. Next, in terms of the random mutations from Y, we are told that 0.1% of individuals carrying Y will randomly mutate to carry Z. And so from Y into Z, that was a 0.1%. or 0.001. Now, if the rest of the individuals remain unchanged, again, that means we've taken care of 0.1% of Y, but the rest of Y has to, or that 0.999 has to feed back into Y. And then the last thing that we're told is that 90% of the individuals carrying allele Z mutate to carry allele X. So from Z, we've got to mutate back into X, and that rate was really high. That was 90% or 0.90. And again, the rest of the individuals remain unchanged. So if 90% of Z is mutating into X, that means 10% is remaining as Z. So once we've got a diagram, now we can write our system of difference equations, or we can write it as a matrix. Either way, I'm going to start with difference equations. So as difference equations, got my x sub t plus 1, y sub t plus 1, z sub t plus 1. And again, what I care about is what's coming into x. So if I look at x, x is feeding back into x at a rate of 0.92. So that's going to look like 0.92 x sub t. The other thing that's feeding into x is coming from z. So I'm going to have 0.9 times z sub t. Now we'll move on to our y's. So coming into y, I've got 0.05 coming from x. And then I've got 0.999 returning from y back to itself. And then for my z's, I've got z coming from x, coming from y, and coming from z. So coming in from x, I've got 0.03. Coming in from y, I've got that 0.001. And from z, I've got 0.1. So there's my diagram, my difference equations, and then if I were to write this as a matrix, here's my x, y, and z, and then the columns tell me where it's coming from x, coming from y, or coming from z. So for my x, I've got 0.92 coming from x, nothing coming from y, and 0.9 coming from z. On my y's, I've got 0.05 coming from x and 0.999 coming from y, and nothing coming from z. And then on my z, I've got a little bit from everywhere. Got 0.03 coming from x, 0.001 coming from y, and 0.1 coming from z.